ACCA, developing professional accountants.
So what is ABC all about? Well, my suggestion here is that it's a better method to calculate a full cost per unit. ABC links costs to the cost unit more accurately and avoids using arbitrary allocation processes. What I'm hoping you're gleaning from that is this. ABC is a response to the key weakness of absorption costing. Absorption costing has been around for hundreds of years, but in more recent years, absorption costing has started to become less and less useful when it comes to providing management information. The basic reasons why it's becoming less useful are firstly because processes are becoming more complex, and the more complex processes become, the less likely that apportionment is going to work in any fair or even semi-accurate way. Secondly, it's likely that there are a multitude of products. Instead of selling relatively few products, it's quite normal for manufacturers to sell tens, hundreds or even thousands coming from a single factory. The more products there are, the more chance there is that some of the products will be wildly overcosted and others wildly undercosted, because it's a more complex environment. And the third basic reason why we have to be so much more careful about overhead is this. In the past, overhead used to be a relatively small part of the total cost. But due to mechanization and many other factors, what we tend to find is that overhead has become a far more substantial proportion of the total costs. So, three basic reasons why we need ABC. So what is our aim? Well, our aim is very simple. It is to calculate an accurate product cost per unit. A cost per unit that we can justify and hence use for further management accounting analysis. Let's start at the very beginning. Let's look at the problem. The problem relates to the use of absorption costing. Now, when we look at absorption costing, remember, it's all about the overheads. The overheads are the fun bit, because overheads by their nature are not directly linked to the product. So we need to find some halfway house that allows us to link the costs to the product. Typically, the way we do that is we apportion to get the costs to the cost centres. So we spread the costs in some fair manner. And then what we do is we absorb using some simple basis, normally based on hours, in order to link the costs from the cost centre to the cost unit. Now, this is how absorption costing works, but the problem is that both of these are arbitrary allocation processes. It's all based on guesswork. As a result of it being based on guesswork, we cannot guarantee that the cost per unit is accurate. And, as I've said before, as things become more complex, it is less and less likely that the cost per unit is going to be accurate. So, if that's what we can't do, what can we do? How can we achieve an accurate product cost per unit? For every problem, there is a solution. And the solution is A, B, C. You may notice here that we've got exactly the same overhead costs and the same cost unit. We're linking overheads to the product. Simple as that. But we're going to do it in such a way that we have an accurate linkage of cost to the product. At least that's the basic underlying aim. Again, please note, it's a two-stage process. But the one thing to pick up on here, and I'm sure you've picked up on it already, is this. When we look at our halfway house, we have something called an activity cost pool. Well, if we just go back a moment, before we used to link our costs to cost centres. And you may be aware that a cost centre is a function. It's simply something that we use to which we can link overhead costs and from which we can link them to the product. That function could be a product line, a manager, a region, a location, or it could be a department, and normally we talk about departments. So how have things changed? Well, the logic goes something like this. The cost centre, being a department, is a noun, a thing, something to which we can link costs. Instead of using a noun, what we do is we use an activity, almost a verb. The idea being that you incur costs by doing something. And if we link our costs to an activity, something that we've done, we should be better able to link those costs accurately. That is the logic. Okay? I'll say that again. The activity is something that we do, if you wish, a verb. And as such, by identifying things that we do, we are better able to link the individual elements of overhead cost to those activities in some accurate way. Now, of course, you could debate whether that's going to happen or not, but we're not going to do that. We are going to swallow it hook, line and sinker and simply say that that allows us to allocate accurately the cost to the cost pools. So, we've linked costs to things that we do, activities. And by doing that, we've been able to do it accurately. And that's got us halfway to where we want to be. What we now want to do is to link from the activity to the cost unit, the product. Now, in order for this to be accurate, we've got to find some link between the cost pool, the activity, and the product. Now, the interesting thing about this is that there's a certain perverse logic to it. You see, is there a link between activity and product? And the answer is there has to be. Because if there was no link between doing the activity and producing the product, why bother having the activity at all? Therefore, there must be a link, and all we have to do is to find out what that link is. Now, this link is called the cost driver rate. All we're saying here is that the cost driver shows the manner in which the activity is linked to the manufacture or production of the product. If we've got that link, we can easily link the overheads to the product in an accurate manner. Can I tell you that in the real world, identifying activity cost pools and identifying the cost driver for the cost driver rate are both very, very difficult. And remember what I said, ABC is particularly useful or particularly necessary when we have complex environments. And the more complex the environment becomes, the more difficult it is to do this sort of thing. And that's one of the reasons why ABC is not taken up that much in the real world. Although elements of it, I think, are used by quite a lot of companies. The great thing from your perspective And my perspective is this. We don't have to do the difficult thing. In an exam question, you'll be given the cost pools. And you'll also be given information that allows you to relatively easily calculate the cost driver rates. And so from our perspective, we simply need to understand how it works from a computational perspective. Okay, let's look at a question. And to illustrate why ABC is necessary, the question's got to have quite a lot in it. So we're going to look at the question bit by bit by bit, and then we're going to come back and look at the answer. Okay? Now, if we look at the requirement, what do we have to do? We want the budgeted product cost per unit. The cost per unit. Do you remember what we've been talking about all along? A full cost per unit. And what we have to do here is we calculate it using absorption costing, and then we calculate it using an activity-based costing approach. Now, I always think this is a bit odd. What we do is we calculate the absorption costing full cost, and there is a single observation we can make about the costs that we've calculated. Yes, absorption costing is inaccurate. They're wrong. Bit mad, really. And then once we've calculated the inaccurate costs, we calculate the accurate costs using ABC. But I suppose the logic goes something like this. If we hadn't done ABC, we would have been relying on the absorption costing numbers. So what we're saying is that the first numbers that we calculated using absorption costings are the numbers, the cost per unit, that we thought were accurate. And then the second set of numbers are the truly accurate ones. So we want to look at how they change and maybe how they change our perspective of how we deal with things. There's quite a lot to read through with this question, so we're going to take it nice and slowly. Hensel has a single production process for which the following costs have been estimated for the period. So please note here, we've got a single process and we've got 3 costs. Okay, they all relate to the same process. Why do you think we've separated out those costs? Well, the reason why they're separated out is this. When we look at ABC, presumably we're going to have 3 different ways of dealing with these costs because they'll all have different cost drivers. Whereas when we look at absorption costing, because they all relate to the same process, we would absorb them using the same labour hours. Okay? Right. 3 products, X, Y and Z, are produced by workers who perform a number of operations on material blanks using handheld, electrically powered drills. Fascinating. The workers are paid £4 per hour. Good money if you can get it. Okay. So we've got a labour rate there, no problem. Then we look at the box of data that we're given. We're given the production units. We're given the batches of material. Now, just an interesting point here, something I always like to pick up on. This information is given in total for the budgeted level of activity for the period of time. Okay? Just something to bear in mind later on. And then we're given data per product unit. We're given the direct material in square meters, the direct material in cost, the direct labour in minutes, and the number of power drill operations. Presumably, all of this will be useful in some shape or form. What are we told? Overhead costs for material receipt and inspection, process power, and material handling are presently each absorbed by product units using rates per direct labour hour. What are we being told there? Well, we're being told at present the absorption costing approach that we use is absorbing everything using the same labour hours. I can say that they are the same labour hours because remember, all 3 of these costs relate to the same production process. Okay? So what we're doing is, at present, we are absorbing, based on labour hours, a simple volume base. What I'm going to do, because they all relate to the same process, is I'm going to add them together and do a single calculation for that. Now, I'm going to stop there for a moment. I do appreciate that there's a little bit of information here about ABC, but to begin with, I'm not interested in ABC. Remember, all I want, first of all, is to get a cost per unit using absorption costing. And that's not difficult. If we go back to the previous slide, I think we already know our material cost. And given that direct labour was £4 per hour, we can relatively easily calculate our direct labour cost. So the first thing we're going to do is get our prime costs out of the way. Okay, if we look at the answer, there are our prime costs. We've got our direct materials and our direct labour. Remember where the direct labour came from? It was £4 per hour based on the number of minutes given, 24, 40 and 60. So what we now need to do is to look at our production overheads. Now, we've got some production overheads there. Strangely, I know that they're right. But let's just check how we went about that. Let's just go away and play with some numbers. To calculate our numbers, what we need is an overhead absorption rate. And if you remember, I said to you that an overhead absorption rate is where we take the budgeted overhead cost divided through by the budgeted level of activity. In this case, the budgeted labour hours. Now, all we have to do is to go and find those numbers. So let's go back to the question and see what we can do. First of all, I want the budgeted overhead cost. And to get the budgeted overhead cost, I simply want to add these three components together. Okay? So here we go. What have we got? We've got 15,600 plus 19,500 plus 13,650. And that will give us our total overhead cost. Now I want our budgeted labour hours. If we're looking at budgeted labour hours, we were given some information about minutes earlier. If you remember, each unit of product X required 24 minutes. I want to put things in hours, 24/60ths. And if we think back, we had 2,000 units of product X. When we looked at product Y, each unit required 40 minutes, and there were 1,500 units of them. And if we looked at product Z, 60/60ths, okay, I'm sure I didn't really have to write that, multiplied by the number of units. So what we end up here with is our total overhead cost divided through by our total labour hours, and from that we can get our overhead absorption rate. The overhead absorption rate being £18.75 per direct labour hour. Okay? So we've calculated our overhead absorption rate, one of the fundamental things that we have to do here. Right, so where have I slotted that number in? Okay, so what we can now look at here is that we've calculated our overhead absorption rate, £18.75 per direct labour hour. What we now want to do is to link that costs to the individual products. In simple terms, we're going to take the figure 1875 and multiply, well, let's just pick this number here. We would multiply by 24/60ths because there are 24 minutes taken on each unit of X. Okay? So, we've managed to get our product cost per unit. Our product cost is 14.10, 18.20 and 28.75. These are the costs calculated under absorption costing. So all we can say about them is, at present, we believe that they are accurate. But deep down, we know that they're probably inaccurate because they're based on guesswork. Right. Now what we want to do is we want to focus on the second part, where we had an ABC investigation, and see what it revealed. Well, it revealed that material receipt and inspection costs were driven by the number of batches of material. Now, what does that mean? Well, what it means is this. The more batches there are, the more the costs are expected to rise. There is a direct linkage between the two. Okay? Remember, I said to you, in the real world, identifying cost drivers is really very difficult. The fact that we're given them like this makes it very easy indeed, and all we have to do is to follow the instructions. Okay? Process power is driven by the number of power drill operations. More operations, more cost. And material handling is the quantity of material in square meters handled. So, because we have this sort of information, we can accurately link the overheads from the individual cost pools, those material receipt and inspection, process power and material handling, to the product. Okay? So, looking for that information, we can go back to the box of data that we were given. We were given a box of data. Do you remember? Material receipt and inspection will be based on batches of material. Now, what did I say about the information that we had here? Well, I said to you that this was in total terms. Okay? And that means we've already got our total number of batches for the period. That will have some bearing in the way we deal with them in the question. If we were looking at process power, it was based on the number of power drill operations. Please remember, these are power drill operations per unit, so we'll have to multiply it by the number of units. And when we looked at material handling, we had the direct material in square meters. So all the information is there in front of us. So how do we go about this? Well, what we want to do is we want to calculate what is described as the cost driver rate. And that's what I intend to do for each of these. Let's go away and calculate the cost driver rate for material receipt and inspection, process power, and material handling. Right, if we're looking at a cost driver rate, some people say that you've got to call it something fancy. But I'm not very fancy, and my view is let's keep it as simple as we possibly can. To my view, and don't let anyone else know this, this sort of computation is very similar to absorption costing. We've just got to be slightly more careful about what numbers we're picking up. So what we're going to have across the top is the budgeted overhead cost. And what we're going to have on the bottom is the budgeted level of activity. Now hold on a moment. All I've done is written for you the overhead absorption rate formula. The basic overhead absorption rate formula. Surely I'm talking rubbish yet again. Well, what I'm trying to emphasize to you is the similarity in what you were doing before and what you're doing now. The only thing I would say is that when we're looking at cost driver rates, we want the accurate budgeted level of activity. But this is the way I want you to think about how you do your computations. Okay? It's too easy to focus on differences. I want you to focus on the fact that you're doing same old, same old. Okay? So, how does this work? Well, let's look at material, receipt and inspection. We know the budgeted overhead cost is 15,600. What we want to do is we want to divide through to establish the cost driver rate. And we said that with material, receipt and inspection, we were using batches of material. Well, okay, let's go and pick those batches up. If we look at the batches, we've got 10 plus 5 plus 16. Okay? Looks a bit odd. Not many batches there. But remember, the batches of material are already in total terms, aren't they? So we had 31 batches in all. Divide one by the other and we get what? 503.23 per batch. 503.23 per batch. Yeah, the mechanics of what we're doing is essentially exactly what we did with absorption costing. We're linking the cost from our halfway house, in this instance the cost pool, to the product, and we're using some base. Here the base is the batch. Now let's look at process power. Well, we had, I think, £19,500 worth of process power. And what we want to do is we want to link it using the number of power drill operations. So if we go back to the question, we see at the bottom that the number of power drill operations are 6 and 3 and 2. What we have to be aware of course, is that the power drill operations relate to the individual unit. So what we have to do here is to link the power drill operations to the units to get the total number of operations for the period as a whole. So what have we got? We said that there were 6 power drill operations for product X and there were 2,000 units of X. There were 3 power drill operations for Y and 1,500 units of Y. And there are 2 power drill operations for Z and there were 800 units of Z. So what we have is 19,500 divided through by this amount, and it comes to 1.0773 per power drill operation. Of course, I could abbreviate that. So, when we do these calculations, it's pretty similar to what we've done before. Pretty similar. And as I said to you, the only thing I would be quite concerned about is that you're aware whether you're looking at total information that doesn't need to be multiplied up by the units or per unit information that does. Okay? Right. So, we've looked at a couple of cost driver rates. Of course, looking at the material handling cost driver rate, it's very similar to what we've just done here for process power. Right. So once we've got to a position where we've calculated our cost driver rates, what we can do is this. If you remember, material receipt and inspection, we had a rate of what? 503.23. And material handling, power, we had a rate of 1.0773. And material handling, I'll just tell you, is 0.7036. Okay? Those are our cost driver rates. Now, I've gone to a lot of accuracy, which you didn't need to, but I quite like to do with ABC myself. How do we link this figure back to the individual product? Well, let's look at material X. How many units were there of material X? Well, there were 2,000 units. And how many batches? 10. Oh, okay. So 2,000 divided by 10 That's 200 units per batch. If we know that each batch is £500, divide it by 200 and you get your £2.52. Okay? What about power? Well, how many power drill operations does each unit of X require? Well, each unit of X requires 6 power drill operations. So all we have to do is to multiply this by 6 to get the value. And how many meters squared does each unit of X require? Well, it's 4. 4 multiplied by this figure, and you get 2.8. So that's the methodology. That's the way it goes around. I would strongly advise that you work through all these numbers to make sure it makes sense to you. Right. Other things that we've got to be aware of with ABC is, where do we use it? Well, of course, the issue I've said already is that ABC only really makes sense if we've got a complex environment, and then it's rather difficult to use. Although theoretically ABC could be used anywhere, you tend to only find ABC in a manufacturing environment. So I've got a couple of observations here. The usefulness of ABC techniques will depend on the characteristics of the organisation. In particular, the following. 1, cost structure. It's particularly useful if you have a high proportion of overhead costs and you have discrete products that you can identify. 2, product mix or diversity. The more diverse the product mix, the more you need something like ABC. 3, information. Is our information system good enough to gather the detailed data that you need for something like ABC? And the environment. Is your environment highly competitive? The answer is normally yes, and if that's the case, maybe ABC is critical to ensure that you understand your cost base. Benefits. Well, more accurate product costing, that's the main benefit that we focus on. It's flexible enough to analyse costs by activity. So, because we've analysed the cost in an accurate manner, we can use that analysis to better understand how it all works. It gives you a reliable indication of the long-run variable cost. Now, this is a fundamental assumption underpinning the whole of ABC. The assumption is that every cost is variable, providing we take it over a long enough time period. Okay? Helps understanding and provides a more logical basis for costing. Now let's look at the limitations. I said earlier, very few people use it. And given all its benefits and the fact that it gives you better information, why is that? The first one, cost to benefit. Implementing ABC is very expensive. What do you get as a result of implementing ABC? Well, all you get is better, more accurate information. That alone is possibly not worth the investment in ABC, unless you can justify that the better decision-making resulting is going to save you a lot of money. Secondly, ABC information is historic and internal. Yes, very much backward-looking, very much inward-looking. All we're doing is looking at our own costs. Does it matter how we rearrange the costs if our cost base is too high? Wouldn't it make more sense to consider what our competitors are doing and whether we are competitive in relation to them? 3, difficult to apply in practice. The answer is yes. And 4, it considers allocation rather than costs incurred. It's a bit like rearranging the deck chairs on the Titanic. Shouldn't we focus more of our time on just reducing the cost base, whatever it is, instead of just making sure that we have a perfect system of allocating costs to individual products? So these are the sort of limitations. In summary, ABC is a big exam topic, comes up quite frequently. You have to be able to deal with the computations in the exam. The key things I want you to take from this lecture are, first of all, the fundamental basis of what we're trying to do. Calculate an accurate product cost. Secondly, be able to do the analysis. And thirdly, be able to discuss what you've done.